Hi there, this is Matt Brown with part 2 of Bluetooth Low Energy Hacking. If you haven't seen part 1, where we did a general overview on Bluetooth Low Energy, I suggest you check out that video first. I will leave a link down in the description. Please like, comment, and subscribe. Please give me feedback on what you liked in my videos, what you don't like in my videos, how I can adapt content to stuff that you like. I'd love all that feedback. And without any further ado, let's jump into the second part of this three-part series where we talk about capturing Bluetooth low energy traffic. So we talked last time about how there's this issue. So sometimes you have encryption, it's optional. You can't tell until you get a hold of that traffic and you start looking at it. So how do we capture traffic with Bluetooth low energy traffic specifically? So we've got all these tools here, and I see it constantly told to the hacker community that if you want to do Bluetooth hacking, you gotta get the Ubertooth 1, and that's the thing that you're gonna use. That's the Bluetooth hacking tool, and I bought it. I have one. I do have to use it sometimes, but I will say it's the least used tool out of everything else that you'll see on the screen here. Part of it's being cut off on my face, but over on the right we have the Nordic Semiconductor NRF 52840. This is a dongle that has a really cool SoC that's made by Nordic Semiconductor. It doesn't just do Bluetooth Low Energy. It also does like Google's new Thread protocol. It does Zigbee. It does a bunch of other stuff that operates on 2.4 gigahertz. Up above, your basic Bluetooth dongle. That can be really helpful, especially if you're operating inside of a VM. Because you can't do Bluetooth stuff inside of a VM unless you have a USB device that's passed through to that VM. But the number one tool that I use for capturing Bluetooth data are none of those other tools that I just mentioned. It is the device there on the left. It is my trusty mobile phone. So we'll talk about how to extract Bluetooth data that has been communicated with a Android phone specifically. There's a bit of an involved process to do it on an iOS device, but it is possible, I've been told. But we won't be going over that in this video. We'll be going over Android. So we have two choices when we want to get Bluetooth low energy packets that are going across the airwaves. The first choice, and this is by far the best choice, is to capture packets from a device that is in your control. Meaning, if the application that you're trying to sniff Bluetooth Low Energy communicates between a smart device, let's say this heart rate monitor that I have on right now, and your phone, well, I don't have a shell on this heart rate monitor, but I have some controls on this phone, and Android does. Android provides me the facilities in the developer tools to take a Bluetooth capture log and to pull that off of the device. We'll talk about that later. But also, if it's communicating with a desktop machine, a Linux or Windows or Mac OS, all of those systems have tools that you can also use. But if two devices that you do not have control over are communicating to each other over Bluetooth Low Energy, then we do have to revert to choice 2 here, and that's where we have to capture these packets over the air. This is a pretty unreliable process. You're dealing with encryption, whereas like we discussed in the first video, if you haven't watched that, again, go back and watch it, because we discussed how in the Bluetooth stack, even if the data is being encrypted with Bluetooth's encryption, if you're capturing on a mobile device, you can capture the data on that host controller interface before the encryption is applied at the link layer, which is a huge advantage when trying to reverse engineer what type of data is inside of that encrypted channel with Bluetooth Low Energy. So So yeah, we have to potentially deal with that encryption. We can't just use the host controller interface to get around it when we're capturing over the air. And this should really just be the last resort, as that last bullet point says. You should start with number one and try to do everything in your power to get a reliable capture from one of the devices in the Bluetooth Low Energy exchange. So how do we pull this data off of a Android device? Well, it's not included in this description, but you enable developer mode. You go and you click like the build number like 7 times, I think it is, and then this option it appears in the developer options. Again, I'm sorry, my face is kind of cutting it off, but you see there it says Bluetooth HCI. That stands for Host Controller Interface, like we talked about last video. Snoop log. So this is going to log all Bluetooth traffic and a bunch of it that you like really don't care about. Some really low level messages between the host and controller that we don't care about, but also all of the good stuff is going to get put into a log file. So I have some notes here in the slide. If it's a rooted device or a not rooted device, this is not a rooted device. I've not rooted this device, so I'm going to be demonstrating how on an unrooted Samsung Galaxy S7 we can pull these logs off of this phone. So the log file, it's named .log. It's not exactly a PCAP file, but you can kind of call it a PCAP file. It can get opened directly in Wireshark. So this is really a grade A option for when we're trying to capture packets, which we will do in a second. So that second method, when we don't control both devices, then we have to go to a sniffing tool like the Ubertooth one. So these Ubertooths are, last time I checked, about $120 a pop. If you want to reliably sniff, so if you remember in our first video, we said that there are 3 advertising channels that a device that is advertising its services on can do that advertising on. And so if you want to observe the first initiation of a connection between a device, a central device, and the peripheral device, then you need to be listening on that channel right when that is happening. So the more reliable way to do this is to have 3 Uber teeth, if that's the plural of Ubertooth. I don't know. But you need to have 3 of those devices, and you need to sniff on all 3 channels at the same time, and then one of them is going to be the packet capture that you want out of it. And again, to be really reliable, you can also use this -T flag, and you can specify the MAC address of the device that you want to target. Like, you only want to follow connections that match a MAC address. That's really the best way to use this device. So you want to figure out what the MAC address of the device is that you're targeting beforehand. There's various ways to do that. And then this can be piped directly to Wireshark Live, but this has always hung for me and has had tons of problems. So I suggest that you use the Linux command below that you see where we use the -F flag to follow connections. That's really important. -T again is that flag to target a specific MAC address, and then -C is going to output the stuff into this PCAP file that we can then open in Wireshark. So we are going to do a Wireshark demo. So the data that we're going to look at is a data dump from this phone when it was communicating to this heart rate monitor. And so just so it's easier to see, we have a couple of filters here. We have a filter and then a menu dialog that are going to be helpful that I've just noted here in the slide. So when we get into Wireshark, it's going to be really important to just get rid of a bunch of noise. If we want to just see Bluetooth Low Energy data that's being transferred, this BTATT filter is going to be very effective. And then there's this really helpful dialog, which we'll get into. But underneath the wireless menu, there's this menu option called Bluetooth ATT server attributes that's going to give us some insight into those characteristics those services that are available and being enumerated by Wireshark with the data that it sees going over the air. So with that, we are not done with the demo. We are going to hop over to our other screen, and because this file actually takes a bunch of time to download over ADB off the device, I'm not going to do that live. I've got the file right here, and so it so basically what you do is you run this ADB bug report command, and then it takes a bunch of time and it downloads this big zip file for you that has a bunch of stuff in it that we don't care about, and then it has this log file right here, and I'm going to go ahead and just directly open that in Wireshark, and we'll full screen this, and then we're going to take a look at what we see here. So again, I open this up, there's a ton of noise that I do not care about at all. So pretty much right away, unless I'm doing some other type of debugging and stuff like that, I'm going to always do a BT-ATT and set that filter. So with that, I'm going to scroll down to the bottom, and we're going to observe some of these messages that are being sent. So here so you can really dig into this, like you can spend a long time digging into this, but I'm going to kind of get to the meat of this PCAP, where we are pulling the heart rate value from the heart rate service off the device. So here are a bunch of read requests and responses. So let's go ahead and take a look at that first, because I think this is some interesting stuff. So and I'll expand the attribute protocol here. So here we are attempting to do a read request on the device name, and the response is CL820 fitness tracker. So there we see it's reading, it's sending a read request, and then it's getting a response back, right? So there's a bunch more of those, and then down here we have this receive handle value notification. And so we can see that the UUID field, it identifies it. It says it's a heart rate measurement. So how can Wireshark know this, that this is a heart rate measurement? So some of these UUIDs, these shorter UUIDs, are predefined in the Bluetooth spec. So there's a bunch of them that are reserved and have very specific mapping. So this UUID 2A37 is the heart rate measurement UUID. That's defined. It's universally defined in the Bluetooth spec. There are other UUIDs that are custom, that allow you to implement your own data protocol over those characteristics using those UUIDs. And so we can see what all of those are by going into that menu I was talking about. So we're going to go to Wireless, Bluetooth ATT Server Attributes. And this is going to give us a little bit of insight into another thing that happens with those characteristics. So each characteristic, like we said, receives a UUID here. And so those UUIDs have a corresponding handle. So the handle is just a short form. So especially for these full-length UUIDs, that way when it's doing a read, it doesn't have to send all this data every time. It can just refer to it as 000E to refer to this really long UUID. And so we can see here that, there's all these different services that are available. And here we can see, again, that heart rate service again, the heart rate measurement service, and its UUID and its corresponding handle, which we should also see back in that request. So here it's saying this UUID's handle is 001C. So if we go back to Wireshark, we will see that right here. here's its handle, 001C. So so you'll notice like this UUID, if I click on this, it's not anywhere. It's not anywhere down here in the data. If I click the handle, it is being sent over the air. That's because ahead of time, up above these reads and writes and notifies, it actually exchanges all of those handle values once at the beginning of the Bluetooth connection, so it doesn't have to ever use that full length UUID again, or any of the short UUIDs. It just uses those short handle, those 2-byte handles, so that makes data transmissions more efficient. So now what we want to figure out, we want to see the heart rate data here in Wireshark. So we are going to click down through here. So we see some 0 readings here. So it's reading the heart rate measurement, and it says a value of 0. I think that was just initially when I put the thing on. It wasn't on tight all the way. And so we will click down, and we see 89, 88, 87. This thing is like very inaccurate, but it does get us some data flying over the air, so that's fun. So that is using Wireshark to inspect Bluetooth Low Energy traffic that we pulled off of our phone that was based on an application that is meant to, use this heart rate monitor to gather that data, and we can see all of those data reads and writes and notifies. We can get all of that from that PCAP that we can pull off the phone, and we can look at it in Wireshark. And that aids in our reverse engineering process. It aids in our security research to see if we can send any of those values, or if we can independently pretend to be this device and send those requests for data to the device. So that's what we're going to talk about in part 3 of our video. So with that, that will conclude part 2, where we discussed how to sniff Bluetooth Low Energy traffic. Like I said, please tune in for the next part, where we discuss how to reach out and interact with Bluetooth Low Energy devices around you. Thanks. Bye.